Hey guys, welcome back. So now we are in the first process of the quality management knowledge area, which is the plan quality management. It's a planning process that creates the project quality management plan. So this would be the primary output of the process plan quality management. As stated in the previous video, so whatever we would discuss, whatever we do, it would be in the planning phase. That portion would be covered in the plan quality management knowledge area. This process lays the groundwork for all the future quality activities. So all the planning processes for all the knowledge areas lays the groundwork for all the future quality activities. Planning for project quality begins early. We want to make sure that how much time it would be my project would take for the testing and the testing phase, which is the quality. Quality plans impact the planning for project scope, time, and cost. So in this case, we are discussing the triple constraint triangle, where scope, time, and cost are closely related with each other. In the triple constraint iron triangle, project quality is tightly linked to the scope leg. So why it is tightly linked to scope leg? Because we want to make sure that only the customer requirements are being fulfilled. And when I talk about requirements, it means I'm talking about scope. The organization quality policy and culture heavily drive the extent of quality plans. So it's not just the project's responsibility to make sure that we are implementing the quality standards, but it's also the organization's capability or policies which they follow. So let's see what are the key inputs. So for inputs, we'll go back to our ITTO sheet. Okay. So we have project management plan. Because we are in the planning process of a particular knowledge area, we would definitely have the project management plan. Then we have the stakeholder register. Why do we have the stakeholder register? Remember, we want what is a stakeholder register? Stakeholder register is a document, you can say, or a file which has the list of all the stakeholders that would be involved in the project. So we want to make sure that all the stakeholders' requirements are being captured, and quality, as you can see, it is closely linked to the scope leg of the iron triangle. That's why stakeholder register is there. Next, we have the risk register. Why do you think we have the risk register? Because quality is a major risk for a project. It could be a positive risk or it could be a negative risk. That's why risk register is there. And risk register, it's a document where we document all the risk. Next, we have the requirement documentation. Yes, we want to make sure that we are fulfilling all the requirements of the project. So requirement documentation, where we have documented all the requirements of the project, is being there. Next, we have the OPA and EEF, which are the common inputs. So baseline is a part of project management plan. That's why it is being here, which says scope, schedule, and cost performance. So there are 8 key tools. First, we have the benchmarking. For the tools, I would not cover the ITTOs because I've already captured all the tools in the PowerPoint slides. So in the video, you would see all these 8 tools. So first is the benchmarking. What is a benchmarking? To measure project quality standards according to those of other projects in order to compare and improve. Most of the time we benchmark a particular project for doing our project. Let's assume that we have a particular project in our organization which has achieved this much percentage of efficiency or something like that, and we want to make sure that our project is something similar to it, and at like, or you can just below that. So that's why we are benchmarking some of the good projects in our organization. Project quality standards, products and processes, both the process and products are covered. Similar industry deliverables, we want to make sure that if we are making a particular deliverable, it is in competition with our competitors, and it's similar or even better than that. Similar projects in organizations, sometimes we for the benchmarking, we do the similar projects which in the organization, which I've already discussed. Next, we have the cost benefit analysis, and I think you remember what is cost benefit analysis. All benefits of quality activities must outweigh the cost. So if you remember in the introduction video, I discussed the cost benefit analysis portion. So we want to make sure that this benefit is always higher than the cost portion. So how it would help, what is the benefits? It would reduce rework, the product would be accepted, cost efficiencies would be great. And how we do it? Planning, inspection, audits, all these things are being used. So let's take a quick recap of the introduction video. The question is, if we have a project A which has a CBR, cost benefit ratio, of 1.4, and we have a project B which has a CBR of 5.6. So which particular project to select? A, option A, B, B, C, none of the two, or option D, which is both of the above. Both A and B, you can say. Both. Both A and B. So CBR of 1.4 and CBR of 5.6. Which one to select? What is CBR? It is cost divided by benefit. Which one is better? A higher number or a lower number? We want to make sure that benefit is larger than the cost. So if benefit is larger than the cost, then the ratio should be less. So if the lesser ratio would be a better project. So in this case, we would go with option A, which is project A. Similarly, if we say BCR is 1.4 for A and for B, BCR is 5.6. Now which one to select? Now BCR is benefit divided by cost. So in this case, we want to make sure that benefit is larger than the cost. In this case, the number which is higher, the ratio which is higher would be selected. So now in this case, we would select project B with BCR of 5.6. So next we have the cost of quality. So this was one of the tool which we didn't discuss in the cost management knowledge area. And I told you in that particular video that we would discuss that in the cost of quality, in the quality portion. So here we are. So cost of quality is cost of poor quality. In cost of quality, we'll say preventive cost and appraisal cost. We'll discuss this in detail. Cost of poor quality is like failure cost, which is the non-conformance rework cost. Okay, so this is one of the slide I have directly copied from the PMBOK. So if you see here, it's directly from the PMBOK, which is cost of conformance and cost of non-conformance. So it is divided into two portion, which is preventive cost and cost of conformance. Let's divide this, cost of conformance and cost of non-conformance. Cost of conformance is divided into two portion, which is preventive cost and the appraisal cost. Prevention cost is training, document processes, equipment, time to do it right. So we want to make sure that conformance, what is the meaning of conformance? Conformance means adherence to the standards. So what first is prevention cost? What are the costs we would spend on the prevention in order to make sure that a product is of high standard, high quality is achieved? We would provide training to our team. We would document the processes. The equipment should be right, time to do it right. So there should be a right time to do the stuff. Similarly, we have appraisal cost, which is assessing the quality, like testing. We check the product whether we have matched the customer's requirement or not. Next, we have the destructive testing loss, and then we have the inspection. So what is destructive testing loss? I'll discuss this in detail. But prior to that, let's first discuss the cost of non-conformance portion. So cost of non-conformance is of two types. One is internal failure cost, and then another is external failure cost. Internal failure cost is rework and scrap. So internal failure, which is found by the project, your project team has found those in the testing phase, like you have to rework, you have to scrap some material or stuff like that. External failure costs are something which could be found by the customer. like you have some liabilities in your contract, so you have, so that is external failure cost. Sometimes you have to do some warranty work. That next we have the lost business, the customer didn't came back to us because of bad quality of a product. So this is cost of conformance and cost of non-conformance. In the exam you may find a question which says, um, which of the following is the example of cost of conformance. So they will give you example like training, rework, scrap, liability. So training is cost of conformance. Similarly, sometimes they may ask you which of the following is a part of appraisal cost. They'll give you example which of the following is not a part of appraisal cost. They can give you example like testing, destructive, inspection, and one of them they can give you scrap. So we know that scrap is an internal failure cost, so it is not the appraisal cost. So let's take an example of destructive testing loss here. Okay, let's assume this is my cell phone. Okay, my hand, my drawing is a little bad, and I'm throwing it from, you can say, 10 feet. Okay, so here is the, I'm throwing this cell phone from 10 feet. I'm checking whether my cell phone would break or not if if I'm throwing it from 10 feet. So that is a destructive testing loss. If in this case, when I throw my phone from 10 feet and if it breaks, that is what you call as destructive testing loss. So you lost the cell phone in destructive. Similarly, sometimes you will send it from, if let's assume from 10 feet it did not break, then you will again throw the cell phone from 15 feet. Now you will check whether this would break or not. So this is destructive testing loss. Next we have the design of experiments. It's a statistical method of systematically analyzing multiple variables to discover the optimum combination of values to achieve a desired result. So in this case, you select multiple variables to discover the to come to a solution to test the quality of the product. So whenever in the exam, if you find the word systematically or statistical, this means we are talking about design of experiment. For an example, let's make a tea. I'm making iced tea. What is the quantity of water I need? How many tea bags I need? How many minutes I have to boil the water? So these are multiple variables which we have selected. So this is design of experiments. Next we have the statistical sampling. Cut down the number of measurements made by only testing a random sample, not the entire population. So sometimes they may ask you on the exam and sometimes they may not ask you in the exam. So let me tell you what is this. Let's assume you have less time for the testing phase. Your customer is wanted to know, I want the product ASAP and stuff like that. So you don't have enough time to select all the sample. So what you will do, you will select random samples out of the entire lot. So selecting and testing those random samples is known as statistical sampling. Then we have the 7 basic quality tools. So in this 7 basic quality tools, there are 7 separate tools in that, which we would discuss in the control quality process. So we can leave it. Then we have the additional quality planning tools. These are same as those. I would request if you can go through your PMBOK for these. And then we have the common one, which is the meetings. So let's see what are the key outputs. So for the key outputs, let's go back to our ITTOs sheet. So the first is the quality management plan would be the output. That's and the process improvement plan. So this is the quality management plan. Let's see what is this. A component of the project management plan that states how the quality policy will be met. Again, how we will proceed, what kind of tools we would be using, all these things would be covered in the quality management plan. The plan contains description of how perform quality assurance and quality control and continuous process improvements will be performed. So this is the process improvement plan where I'm showing you the plan, do, check, act. I've already explained you what is this with an example of a burger launched by the McDonald's or by some other vendor, I don't remember. a component of the project management plan that states how the quality activities would be streamlined and improved. That's the process improvement plan. Next, we have the quality checklist, a specific set of process steps to be followed consistently, both in a manner and in sequence. So in this case, you would have a checklist where you would say, okay, so is this done? Point number two is done or not. So this is a kind of a checklist where you would go through all the points which are marked in that. Checklists are created and documenting to the plan quality for later use in the quality control. So checklist would be created here, but it would be used majorly in the quality control process. Next, we have the quality matrices. The plan measures and targets related to quality of the deliverables as well as the processes. So we have a specific matrix, the targeted measure that define when the specified quality is achieved. So in this example of dropping a cell phone, so at that time I want to make sure that let's assume I'm clicking a picture from my from cell phone's camera. So I want to make sure that this should be of this much pixels, or this should be of X number of HD or stuff like that. That's the specified quality which is measured. Rapid response time does not define a metric, it is not measurable. System response within 2 seconds. 99% of all requests of simultaneous users. So if you're responding, if the system is responding in 2 seconds, this means we are talking about quality matrix, because the specific quality we have documented is 2 seconds in this case. So let's review the keys. What are the inputs which we discussed? We discussed the requirement documentation, the baseline is the plan quality management plan. Then we have the stakeholder register, risk register. We have the common ones, EEF and OPA. We did lot of tools. We did benchmarking, cost benefit analysis, cost of quality, design of experiments, statistical sampling, the basic quality tools, some additional tools, and meetings. The outputs, we had the quality management plan and the process improvement plan. Process improvement plan, we did the plan, do, check, act, the Deming cycle. Then we have checklists, matrices, and document updates. So focus your efforts on understanding the primary output, which is the quality management plan. Know the 8 key tools. In this case, the tools are more important. Know that plan quality begins early. We want to make sure that we have specifically documented the testing and the quality process. Know that the quality of both the deliverable and processes are goals of plan quality. So we want to make sure that we are not just focusing on deliverables, but we are focusing on the processes as well. Know that the process improvement plan is an output of this process. Process improvement plan, when I talk about process improvement plan, remember we are talking about the plan, do, check, act. Okay, so this marks the end of the end of the plan quality management tool. So next we would be discussing the quality assurance, which is the prevention